Hello student, myself Neeraj Pandey, and today we discuss some other chemical property of alcohol. Okay, let us start. What happens when alcohol react with PCl5? Okay, first question, what happens when alcohol react with PCl5 or PCl3, phosphorus pentachloride or phosphorus trichloride. Okay, answer is that when alcohol like RCH2OH react with PCl5 like Cl and Cl. Here 5Cl directly bonded with phosphorus atom, but due to presence of high electronegativity, this bond break toward chlorine atom. As a result of this, chlorine form negative charge and phosphorus form positive charge. In this situation, one bond also break toward chlorine atom due to high electronegativity than phosphorus. In this situation, the electronegativity of oxygen is greater than hydrogen as well as carbon. Thus, if both the bond break from carbon and hydrogen toward oxygen atom, then oxygen form 2 negative charge, hydrogen form 1 positive charge, and carbon also form 1 positive charge. This positive charge hydrogen attracted by the negative charge of chlorine, and this negative charge chlorine also goes toward the positive center of carbon atom. As a result of this, formation of RCH2Cl chloroalkane takes place, and this 2 negative charge oxygen comes or attracted by the phosphorus, because phosphorus have 2 positive charge, oxygen have 2 negative charge. In this situation, POCl3, phosphorus oxychloride, is formed, and 1 HCl molecule also comes in this reaction. Okay, next, if we take different type of alkyl group in place of R, like CH3, CH2, OH2 plus P, Cl, and Cl, then this chlorine and hydrogen both are combined to form HCl, because it becomes negative charge after breaking the bond from phosphorus, and it also becomes negative charge and goes toward carbon atom. This oxygen attract electron from both sides, hydrogen and carbon, to form 2 negative charge oxygen atom, and carbon become positive charge. This Cl attack toward this carbon center. As a result of this, formation of CH3, CH2, Cl, ethyl chloride or chloroethane are formed, and POCl3 phosphorus oxychloride plus HCl are also formed in this reaction. Okay. Next question arises that what happens when alcohol reacts with what happens when alcohol react with copper. Okay. Answer is that when alcohol react with copper at 375 degrees centigrade, then it form aldehyde as well as ketones. For example, R CH2OH RCH2OH when react with copper at 375 degrees centigrade, then firstly this bond break toward oxygen atom. Due to this region oxygen form negative charge, and this bond break toward hydrogen atom. As a result of this become positively charged hydrogen and negative charge hydrogen. This negative charge hydrogen attract positive charge hydrogen to become hydrogen gas, and oxygen negative carbon positive become double bonded system like R C double bond OH. You can write this RCHO. It is an aldehyde. Okay, and formation of hydrogen gas takes place. You can see here CH3 CHOH. Further it react with Cu 375 degrees centigrade. This bond break toward oxygen atom and this break toward the hydrogen atom. As a result of this it form CH3 C double bond O and H. Formation of H2 gas takes place. You can see here in presence of copper alcohol change into aldehyde, but if we take 2 degree alcohol like CH3 CH3, this carbon contains hydrogen and OH group. In presence of Cu and 375 degrees centigrade, when this bond break toward oxygen atom and this bond break toward hydrogen atom, then in this situation CH3 C double bond O. It is acetone. Acetone. Okay. Isopropyl alcohol or 2-degree alcohol. 2-degree alcohol when react with copper in presence of 375 degrees centigrade, then it change into acetone. Okay, then it change into acetone, and after formation of acetone, formation of H2 gas takes place. It is the simplest reaction of alcohol in which alcohol undergoes reduction division in presence of copper. This reaction also takes place in presence of aluminum hydride. This reaction also takes place in presence of aluminum hydride. Okay. Next question arises from this chapter, and from alcohol. What happens when alcohol react with thionyl chloride? What happens when alcohol react with thionyl chloride? Okay, you can see here SOCl2. It is the thionyl chloride. Okay, what happens when alcohol react with SOCl2? You can see here R answer. ROH means alcohol, CH2 and OH react with thionyl chloride. Thionyl chloride means double bond oxygen O and 2 chlorine atom directly bonded with sulfur. Okay, in this situation, firstly this bond break toward chlorine atom, and also this bond break toward chlorine atom due to high electronegativity of chlorine, and sulfur become positively charged species with two positive charge. Here, when oxygen attract the electron from both sides, carbon and hydrogen, then it become two negative charge oxygen act as nucleophile, and this oxygen attacks toward the sulfur atom. This chlorine also attract the proton from alcohol to form HCl, and this chlorine goes toward the positive charge carbon in alcohol. Okay, this reacts. After this reaction, formation of R CH2Cl haloalkane plus SO2 plus HCl takes place. If you take different type of alkyl group in place of R, like CH3, CH2, OH, then in presence of SOCl2, it change into CH3, CH2Cl plus SO2 plus HCl. I hope you betterly understand how it is possible. And next question, what happen when alcohol react with PCl3, phosphorus trichloride. Okay, this part are not explained in next topic. Thus you can see here answer is that R CH2 OH plus PCl3. Okay, in this reaction we take 3 molecule of alcohol, and when these are heated then it form R CH2 Cl 3 molecule plus POH trious phosphorus trihydroxide are formed. If you take different type of alkyl group, then 3 molecule of ethyl alcohol react with PCl3, then all the chlorine atom move toward carbon and all OH group comes toward phosphorus. In this way 3 molecule of CH3, CH2 and Cl are formed with formation of POH trias. Takes place. Okay, it is ethyl chloride. Okay, next question arises from alcohol. What happened? Question is that what happens when alcohol undergoes oxidation reaction. Okay, then you can write it when alcohol like R CH2 OH react with undergoes oxidation, then this reaction occurs in presence of K2Cr2O7 or K2MnO4 or KMnO4. Oxidizing agent here potassium dichromate and potassium permanganate are used for the oxidation. Due to this process, first time this bond break toward oxygen atom firstly this bond break toward hydrogen atom. Due to this reason carbon become positive charge, hydrogen become negative. You can also break this bond toward carbon atom because carbon form both, hydrogen form both positive charge and negative charge. If you break this bond toward hydrogen atom, then in this oxidation when oxygen comes toward this carbon center, then it become acetic acid, carboxylic acid like R C double bond O OH plus H2, but actually here two steps involved in the formation of carboxylic acid. You can see here like CH3 CH2 and OH. Okay, firstly in this reaction which occur in presence of K2Cr2 O7. Firstly it break into CH3, C double bond O and H. After removal of two hydrogen atom from this side and this side, and when hydrogen comes out from the reaction in the form of gas, then further oxidation takes place and this aldehyde, acetaldehyde, change into acetic acid, and it is acetaldehyde. I hope you betterly understand when any alcohol undergoes oxidation in presence of K2Cr2O7 or KMnO4, then firstly it change into aldehyde, then it change into carboxylic acid. The above reaction in which we directly change this alcohol into carboxylic acid, it is also right, but one step in this reaction also takes place when alcohol undergoes oxidation. Firstly it form aldehyde, then it form carboxylic acid. Okay, I hope you betterly understand that alcohol so different type of reaction. After this special type of reaction which is appear in case of alcohol, we try to understand what is the chemical or physical property of phenol. Okay, what is the properties of phenol? Property of phenol. Before the discussing of property of phenol, I want to explain about some things of phenol, that phenol in which hydroxyl group is directly bonded with the benzene ring, then it is known as phenol. Although it is denoted by or indicated by C6H5OH or PHOH or AROH. Okay, here symbol PH indicate about the phenyl ring. After removal of one hydrogen atom from benzene, it is known as phenyl ring, or AR stand for the aromatic hydrocarbon or aromatic ring. Okay, thus it is denoted by C6H5OH or PHOH or AROH. In this situation, hydroxyl group directly bonded sp2 hybrid carbon of the benzene ring. But one question arises, what is the property of phenol? Phenol is most common and important compound which is generally used in our daily life, like hospitals and our houses to clean the furnaces. Okay, let's start. Physical property. Physical property of phenol. Properties of phenol. What is the physical property of phenol? Okay, first point, phenol is colorless liquid or solid. Phenol is a colorless liquid or solid. On cooling, phenol change in the form of solid, but on heating it change into liquid. Thus it show both the state. They may be present in the form of liquid or in the form of solid. Second is phenol is also used in hospitals and in houses for clean the furnaces. Okay, except this phenol is insecticides because due to its smell the insects are not comes in houses or hospitals. Third point is phenol always have corrosive action for the skin, okay. Fourth point, phenol are soluble in water. Phenol are soluble in water and also in different types of organic solvents. Okay. Fifth point is that phenol is always have higher melting point and boiling point due to intermolecular hydrogen bonding. Okay, these are the special property of phenol. If we know different type of action about the phenol, then it is very necessary to us that we further know about the chemical property. But before the explanation of chemical property, I also explain about different type of question which are arises from this point. And question number first is, why phenol is soluble in water? Okay, why phenol is soluble in water? First question, why phenol is soluble in water? Answer is that due to intermolecular hydrogen bonding, phenol is soluble in water. Due to presence of intermolecular hydrogen bonding, phenol are soluble in water. You can see here oxygen, hydrogen, oxygen, hydrogen, oxygen, hydrogen, oxygen, hydrogen, and so on. Here benzene ring is directly bonded with oxygen atom. You can see here all the area where oxygen is present is directly bonded with benzene ring. Okay, due to presence of hydrogen bonding, phenol is soluble in water. Second question arises from this topic. In alcohol and phenol, which will be more soluble in water? Okay, it is the second question. Question number second. Answer is that alcohol is more soluble in water than phenol, because in alcohol number of carbon is less than the number of carbon of phenol. And you also know that the solubility and we know that the solubility of alcohol decreases on increasing the number of carbon chain or molecular mass. Okay, in case of phenol there are 6 carbon present, but in case of methyl alcohol, ethyl alcohol, propyl alcohol, there are only 1, 2, 3 carbon atom are present. If the number of carbon increases, then the solubility of alcohol or the compound which contains alcoholic group decreases in the water. But both are soluble in water, alcohol as well as phenol. But you can say that the alcohol are more soluble as compared to phenol, and reason is this. Okay. Second question, which arises from this point of view, that question number 3, why phenol acidic in nature, why phenol is acidic in nature? You can say that answer is that phenol is acidic in nature due to loss of proton. It can form phenoxide ion. Phenoxide ion means conjugate base, and every type of those compound where after removal of proton formation of conjugate base takes place are acidic in nature. Thus phenol is acidic in nature due to loss of proton. It can due to loss of proton because it can form phenoxide ion or conjugate base. Okay, you can see here it is the phenol. After removal of H plus, it can form phenoxide ion intermediate. According to Branchard-Lowry acid base concept, acid is a proton donor, and here phenol donate the proton, thus it is acidic in nature. And from this point of view, it is clear that phenol are acidic in nature. But one question also arises that in case of in case of phenol and alcohol which will be more acidic and why? Answer is that phenol is more acidic than alcohol because it form more stable phenoxide ion intermediate due to resonance effect while in alcohol resonance is not possible. Okay, phenol is more acidic than alcohol because in case of phenol it form more stabilized phenoxide ion as compared to alcohol. Due to resonance effect, phenol can form phenoxide ion intermediate. You can see here how phenoxide ion intermediate is more stable as compared to alcohol. Okay, here it is the structure of phenol. Okay, after removal of H plus from the phenol, formation of phenoxide ion takes place like this. Oxygen become negative charge. It is the phenoxide ion. This bond break toward this carbon atom because if we break this bond toward this oxygen atom, then oxygen contains negative charge, and it also when become negative, then negative repulsion takes place. To avoid this deficiency, this bond always break toward the second carbon atom. As a result of this, it is the resonating arrow. As a result of this, formation of carbocation intermediate takes place. This to make balance this negative charge, this bond also break toward this carbon atom. As a result of this, this carbon become positive and this carbon become negative. Okay, the negative charge is localized in the structure. Further, next structure, after breaking of this pi bond toward this carbon center, and formation of this type of structure where C double bond O double bond and one negative charge. Further, this bond break toward oxygen atom, and when this bond break toward oxygen atom, then further phenoxide ion takes place with the localization of the pi bond. Okay, resonance is a process in which structure of pi bond change, and you can see here the structure of pi bond change in all the structure, and all this structure from here to here is resonance stabilized carbon ion, but here this structure shows resonance stabilized phenoxide ion. Okay, so due to phenoxide ion, stabilized phenoxide ion, phenol is more acidic as compared to alcohol. In case of alcohol or CH2OH, there is no resonance. Okay, due to this reason it is less acidic than phenol. If we try to understand what is the another acidic behavior of phenol, then it is very necessary to know that acidic strength of phenol depends upon following two factors. Factor first, if phenol contains electron withdrawing group, and second factor, phenol contains electron donating group. Okay, if you know what is electron withdrawing group and what is electron donating group, then you can easily understand what is the acidic strength of phenol. Let us start about this topic. If electron withdrawing group withdrawing group increase the acidic strength of phenol at ortho and para position like halogen, halogen group, nitro group, NH2 minus. Okay, NH2 minus. If these group are present and attached toward the ortho and para position, then you can explain the acidic strength of the compound increases. You can see here By example, it is the structure of phenol. It is the structure of phenol. It is the structure of NO2. It is the structure of phenol where NO2 are present, and it is the structure of OH which contains NO2 and NO2. Okay, if we explain the acidic behavior, then the number of electron withdrawing group increases in which phenol is less acidic than orthonitrophenol. This position is ortho, this is meta, and this is para. Okay, orthonitrophenol. Orthonitrophenol is also less acidic than ortho and para-nitrophenol. Ortho and para-nitrophenol. If we remove nitro group from ortho position, then it is also more acidic as compared to orthonitrophenol. Okay, it is the para-nitrophenol. Okay, and in this structure ortho and nitrophenol are present. Okay, trinitrophenol are present. It is also known as picric acid. Picric acid 2,4,6 trinitrophenol. It is its IPAC name, and it is more acidic as compared to phenol. If there is phenol is present, another structure where phenol with halogen atom like chlorine, bromine, iodine, you can write here chlorine also, and chlorine OH is present, then it is less acidic and it is more acidic. This acidity increases as the position of electron withdrawing group different, है ना, not same. In this structure, this position of chlorine toward ortho, and here chlorine is present toward the para position of phenol, and para position of phenol with electron withdrawing group is more acidic as compared to the electron withdrawing group which are present toward the ortho position, and phenol is less acidic as compared to this. Except this, if there are electron donating group is present, then acidic character decreases. Acidic character decreases, like electron donating group decrease the acidic behavior of phenol. For example, if there is phenol, there is CH3 orthocresol, and there is CH3, then it is known as paracresol, and if there is OH and CH3 is attached toward the meta position, then acidic behavior of phenol decreases. Okay, it is less acidic than paracresol or orthocresol or phenol. In these structure, phenol is more acidic as compared to this. Here CH3 group act as electron donating group or bulky group, or it is also known as alkyl group. Okay, if the alkyl group are present, then acidity of the phenol decreases and basicity increases. The basicity character increases with presence of electron donating group and acidic character decreases. I hope you betterly understand what is the acidic property of phenol and how the acidic behavior are differ according to electron withdrawing group or electron donating group. Okay, after the knowledge of acidic strength, we try to understand different type of chemical reaction which is most important for the examination viewpoint. Okay, so let's start about the chemical reaction of phenol. Chemical reaction are chemical properties of phenol. There are large number of reaction which appear in case of phenol are explained. Most important reaction. Question number first. What happens when phenol react with conc H2SO4. Okay, it is the first type of question, but another type of question also arises from this point. How can you prepare phenol sulfonic acid? How can you prepare phenol sulfonic acid from phenol? Okay, or one question also arises. Complete the following reaction like C6H5OH plus conc H2SO4. Okay, then what happened? And in examination ask complete the reaction. There are three types of reaction are possible in case of this. One question also arises, what is the sulfonation of phenol? One question also arises, what is sulfonation of phenol? Okay, answer is that when phenol react with conc H2SO4, then it form a mixture of orthosulfonic phenol and parasulfonic phenol SO3H by the removal of water. Okay, orthosulfonic phenol or parasulfonic phenol are formed when phenol react with H2SO4. Its mechanism also ask in your examination hall, that what is the mechanism of this reaction. You can see here mechanism. It involves in following steps. Step first, formation of an electrophile. Okay, firstly the H2SO4 like C double bond O, OH and OH. In this situation, this bond break toward oxygen atom and it form HSO3H with positive charge and OH minus. It is an electrophile and it is an nucleophile. In first mechanism, formation of electrophile takes place. The second mechanism, in step second, formation of resonance stabilized carbocation intermediate. Formation of resonance stabilized carbocation, not carbocation, carbanion intermediate. How it is possible? You can see here. Firstly, when oxygen contains 2 lone pair of electron and pi bond is present in case of phenol. Firstly, when this bond break toward this carbon atom, then it become negative. At this time, this lone pair of electron goes toward the positive center of carbon. Thus, in first structure where OH become positive charge, it become negative and 2 pi bond is present. Further, this bond break toward para position of the phenol and it can form this negative charge toward this center, and here oxygen positive charge with hydrogen. Further, this bond break toward this center and negative charge move toward the ortho position of phenol, and here O plus and H both are formed plus etc. It is the resonance stabilized carbanion intermediate. Okay. In third step, in third step step third, when this carbanion intermediate, when resonance stabilized carbanion react with electrophile, then it form addition product or adduct, where Bronsted Lowry acid base reaction gives final product, final product. How it is possible? You can see here in first structure where second carbon contains negative charge, oxygen contains positive charge with hydrogen and 2 pi bond is present. It is the resonance stabilized carbanion where electrophile SO3H sulfonic acid is present. This electrophile attack toward the negative center of carbon, and in this situation double bond O plus H and SO3H, it is the negative charge. In this situation, one hydrogen is present in each carbon center. Okay, it is an adduct, and in first step where OH act as a nucleophile are present. Okay, this OH attract hydrogen when this bond break toward this carbon atom. Due to high electronegativity of oxygen, pi bond also break toward the oxygen atom. Then oxygen become neutral and this center become positive. This positive center and this negative center combine to form a pi bond combine to form a pi bond where SO3H is present and it become phenol. Okay, then its name is phenol sulfonic acid. Okay, and this H plus attracted by OH to form H2O. On the basis of this mechanism, step first, step second and step third, you can easily understand what is the mechanism of sulfonation of phenol. Okay, you can take any screenshot and write in such type of reaction. Second reaction of phenol is also very important, which are always asked you in your examination, that what happens when phenol react with nitric acid. What happens when phenol react with nitric acid, or what is the nitration of phenol? How can you prepare nitrophenol when phenol react with nitric acid? Okay, you can see here. Question is that what is the nitration of phenol? Okay, you can write their answer. In case of nitration of phenol, when phenol react with dilute HNO3 in presence of conc H2SO4, in presence of conc H2SO4, then at 298 Kelvin it form orthonitrophenol, while at 375 degrees centigrade it form paranitrophenol. Okay, you can see here, it is the structure of phenol, and phenol react with dilute HNO3 in presence of conc H2SO4, dilute HNO3 in presence of conc H2SO4 at 298 Kelvin, phenol change into orthonitrophenol plus water plus H2SO4, and in second step it also react with conc H2SO4 at 375 degrees centigrade, it change into nitro group, not degree, it is Kelvin, it is Kelvin temperature. Okay, and also you can see here it is para nitrophenol, and ortho nitrophenol. Okay, plus H2O plus H2SO4. Here H2SO4 act as catalyst which comes out in the reaction as such. Okay, one property of phenol in this reaction also possible, that when phenol react with conc H2SO4 and large amount of conc HNO3, then it form picric acid. You can see here it is the structure of phenol react with conc HNO3 and conc H2SO4. It is an excess amount to form OH, NO2, and it is the picric acid. Okay, it is the two type of reaction of nitrophenol, where in a small amount if we dilute HNO3 are used in presence of H2SO4, then it form a mixture of ortho and nitrophenol. But if we use conc HNO3 in excess amount with conc H2SO4, then it form picric acid. Okay, but its mechanism is also asked in your examination hall. Then what is the mechanism of nitration? What is the mechanism of nitration of phenol? What is the mechanism of nitration of phenol? Okay, so let's start. Mechanism. It involves in following steps. Step first, formation of an electrophile. When HNO3 like H H O N double bond O N double bond O. It is the structure of HNO3. React with H2SO4 like it is a structure of H2SO4. When this bond break toward oxygen atom, then oxygen become negative charge, hydrogen become positive charge. This bond also break toward oxygen atom. This negative charge oxygen attract the hydrogen toward itself. After this reaction, formation of H2O, NO2 positive charge and HSO4 negative charge takes place. Okay, it is an electrophile and it is an nucleophile. Electrophile is a positively charged species or Lewis acid, and nucleophile is the negative charge or Lewis base. Step second, formation of resonance stabilized carbanion intermediate. How it is possible? You can see here. Firstly, it is an phenol. This bond break toward this atom, and this lone pair of electron of oxygen comes toward the positive charge of carbon. Due to this reason, formation of O plus H negative charge plus not plus, this bond break toward next carbon atom or fourth carbon atom to form pi bond and negative charge OH and H plus. Further, this pi bond break toward this carbon center to form OH plus negative charge, and here positive charge, further if this bond break, then it become phenol. Okay, it is the resonance stabilized carbanion intermediate. Step third, this carbanion intermediate resonance stabilized carbanion react with carbanion react with electrophile to form adduct, where acid base reaction, Bronsted-Lowry acid base reaction, Bronsted-Lowry acid base reaction gives final product. Okay, you can see here when double bond O plus H react with NO2, which is an electrophile, then this bond attract NO2 toward itself, by which formation of NO2 hydrogen double bond OH. Okay, in this reaction when this hydrogen breaks and oxygen also attract pi bond toward itself, then HSO4, which is present in the reaction, attract the hydrogen toward itself to form H2SO4, and this phenol become neutral where NO2 is present, and it is the ortho nitrophenol. It is the main product of the reaction. Okay, if we take here para-carbanion, then we can form para-nitrophenol. Okay, it is the main reaction of the mechanism of the nitration of reaction. It is very important for you that there are different type of reaction which involve in the formation of different type of product which is related with the phenol, can be asked in your examination hall. If you easily understand what is the property of such type of reaction, then you can easily understand. Okay, next reaction, which is also most important, what is the name is the Friedel-Crafts reaction. Okay, and yesterday I tell you about the chemical property of alcohol. Today we discuss different most important reaction and mechanism of the phenol and alcohol both, and next day I discuss about different type of chemical property of alcohol. Thank you.